All right, so that's on making a graph. Numbers get bigger, numbers get smaller. This one we might use later down the road. Information in economics is not always perfect, and so this idea of a scatter plot, where we've collected information here on box office ticket sales and DVDs sold. So tickets sold and DVDs sold, the connection between those two things. Do people go to shows and get DVDs or not? Here's what they look like in space. So we collect information and we can plot those points. That can be helpful in establishing the relationship between two variables. Would this be a positive relationship or negative relationship between box office tickets sold and DVDs sold by looking at those points? Positive. Now, why do you say that? Why do you agree with that?
Yeah.
What makes it a positive relationship?
Well, I don't know, they're going that way.
Okay, they are going that way, so that helps. Let me come down here. Increasing, so what do you mean by that? Okay, so what's going up and what tell me a little bit more, yes?
Going from 5 to 6.
5 to 6, okay, so who wants to put it, Natalie, can you help out here? I'm agreeing with what you guys are saying, I want to be a little more formal about it.
As the DVDs being sold increases, the higher the ticket sales.
Good, good. So they're kind of correlated with each other. Now, with this particular, and economists and statisticians struggle with this sometimes, do we know that there's causality? In other words, does this cause that one to go up, or does that one cause this to go up? We don't necessarily know that right away. Now, when we did a demand curve, that's different. I was saying that the price was driving the quantity, right? So the independent variable was price. Higher prices led to less sales because people aren't buying as much. So that was a negative relationship. Here, we're just observing a correlation, not necessarily causation between these two things. So the positive thing here is if we were to try to statistically fit a line, we can see that there's a lot of points going this way. It tends to have that upward slope. If we were to put a function in between these two to fit a line, you can see that if we tried to put something, it would look like that. And so that means there's a positive relationship between box office ticket sales and DVD sold by just looking at those points. Okay, so this whole business, we're going to see it throughout the semester quite a bit of positive and negative or independent relationships between variables in this case. And variables, again, are just whatever you're measuring on the axes. All right, questions or comments on that? Okay, here's a couple more down. There we go. So we can measure anything on there. Unemployment and inflation. Do you see any relationship here? Do you see a line that could possibly be fit through that? Maybe something slightly negative, maybe, but we just don't know. So what we really do is we use some more sophisticated statistical techniques to do that. It might turn out that the line looks like this. If that's the case, then these two things are unrelated to each other. There is no correlation between the two. So sometimes it's hard to visually tell. Here it's a lot easier, right? Income and expenditures. People have more money, they spend more money. Nice positive relationship between those two.
One of the questions in the appendix is like, it shows you a graph and it's like, is this like GPA compared to all, like number of times you watch DVDs, or like, it was like miles per hour, like in gas, like I had no idea how you would choose which one it is.
But was it just looking for you to make an inference off points, kind of similar to what we're doing here?
Yeah, I like had a graph and it's just like, what are they trying to show you? And it gave you 4 things that I don't know.
Okay, yeah. And so, and that's natural that sometimes our gut feeling says, well, you want to tell the story right away, right? So once you get more sophisticated at analyzing this stuff, you kind of want to step back and say, okay, so you look very mechanically at it. Like, oh, okay, well, I can see that these two things are positive related. And try to avoid telling the story of, well, what's the difference between how fast a cheetah runs and the rate of ice cubes melting, right? I don't get it. Why are we even looking at it? So you don't always want to try to tell that story early on and kind of have this step-by-step approach to analyzing it. And then at the end of the day, we're look at what the question's asking, and is it asking whether there's a positive or negative relationship? I'm not exactly sure what that question was. But
Yeah, it was just like.
try to step back, because what we're going to find as we get into the material is some things are going to be counterintuitive. You're going to think, your gut's going to tell you, well, I think the world works this way, but the data shows something different. And so some things we'll find that way, that they're counterintuitive. All right, anything else on that one? Okay, so here's some more pictures of positively related things. So speed, distance, sprinted, study time, problems worked, recovery time, distance covered in 5 hours. So again, we don't necessarily know what they are, but it's important to read the axis and see what we're measuring. That would be my first suggestion when you look at a graph, what are we measuring? And then if the function looks like this, these are all three positively related, but they've got a little extra morsel of detail to them. It shows how they're related. So this one is increasing at a decreasing rate. So it's going up, but at a slower and slower rate. So it's falling off. The rate of increase is falling. This one is increasing at an increasing rate. It's like it's accelerating up. This one is a linear relationship where each increase is matched by the same rise and run each time. So it's a linear relationship. But all three are showing a positive relationship between the variables. They're all increasing or positively related. So that's another variation that we're going to see a lot. I'll just give you a heads up. This increasing at a decreasing rate is a big one in economics. We're going to see that come in later in the chapters on cost, as well as in the utility chapters.
Just put that like, say it's like a car and it's like speed. So that would be like the car is going the same speed the whole way up, like a linear one. And the other one's like it's just slowly gaining and then it's like planing off.
Yep, like, there's something changing, yeah. So here we got,
it's like speed.
So this was recovery time and distance sprinted. So if you sprint 300 yards, we look at the recovery time needed to do that. But if I sprint an extra 100 yards, from 300 to 400, my recovery time jumps up quite a bit more compared to my first 100 yards, right? In either case, I sprinted 100 yards. But my first 100 yards, I was able to recover in 5 minutes. But if I ran a 300 and then was asked to run another 100 right away, to run the difference between here, the difference is 100 yards. It's the same distance. But the recovery time is much greater. So the recovery time is increasing at an increasing rate, the relationship between those two things. We're going to have lots of applications of that. So right now, it's just important for you to recognize that there's differences of increasing functions. One thing you might jot in addition to that was we're going to see a function that looks like this. It's got both going on. Right, so we got this little inflection point. See how it looks like that one, B, and then it flips to C. So you can have combinations of functions. So here it's increasing at an increasing rate and then diminishing eventually. It depends on what we're looking at, yeah. It's possible that it could drop down, it could go up again, it could flatline. So all we're doing now is just thinking about the three possibilities and then acknowledging that there could be mixes of them. Okay, anything else there? We saw with the production possibilities curve, this one. So our production possibilities curve was bowed outward because the opportunity cost was changing. So they're all negatively sloped. They all have a negative rise over run. We're going back to down, over. We're doing the same thing, down, over, down, over. But the shape of the function is giving us different results. And so these are simply the three cases, just like we just did with the positive case, for negatively related variables. Most of what we've done so far with demand curves, in fact, what we'll stick with throughout the semester has been a simple line for a demand curve. But really, the demand curve looks like this. The real world demand curve kind of looks like this.
And that one's decreasing at a decreasing rate?
Let's see.
So it's getting less steep?
So it's decreasing, and is that flat? Is this flattening thing decreasing at a decreasing rate?
Because it would get steeper if it was at an
But it's getting
right?
more.
Right, so this one's becoming steeper,
I
so
know.
it's at an increasing rate, right?
Right.
So the fall, the result is getting a bigger jump. Okay, so for this class, if you were, this one's key, and this one's key. Well, I take that back. We're going to use one like, we're going to use all three. I was going to say that maybe less on this one, but we're going to use that in chapter 8. Okay. Here's what we did today in class with that total revenue function. Now these are just mixtures of what we just looked at, right? Here's the production possibilities frontier bowed outward. Here is increasing at a decreasing rate. So this is a mix of a positive and negative action going on. So it topped out. And we can think about it U-shaped, which we'll see when we get to cost. Over this range of speed, gasoline cost is falling. My car becomes more efficient. But as I go faster and faster, my gasoline cost goes up. What they're showing here, there's kind of an optimal level, an optimal speed to drive for this particular car. I don't know if they totally made this up or not, but imagine driving 55 is ideal to minimizing for fuel efficiency with your car. As you start to push that engine further and further, it uses more and more gasoline on each incremental mile, and so my cost per gallon goes up. Same thing if I'm going too slow. It's not operating at that exact perfect hum as it does at 55, and so it becomes a little more costly there. So at 55 miles an hour, we've minimized that function of our gasoline cost. Okay, so we're always thinking about relationships between variables, and they can take on a number of different things. Questions on that one? Unrelated. When you see things with a straight line, the two variables aren't related. It doesn't matter what the price of bananas is. If bananas go up, your grade in economics is going to stay 75%. Right? Your grade in econ is independent. If bananas are really cheap at 40 cents a pound, or double in price to 80 cents a pound, right? Bananas has nothing to do with your econ knowledge. So it's independent. And so that function ends up being a flat line. And then it can also go this way if we think of it in terms of the other variable. Wine and rainfall are unrelated. Rainfall in California and French wine. Doesn't matter. It depends on the rain that's happening in France. So if we were to graph the rain in France and the output of wine, what would that look like? What do you think that would look like? This is a good stretch of your brain. So we got rain in France and the output of wine. So at 0 rain, do we get any grapes? No, it's probably not so good. As it starts to rain, we get wine. So it's going up. So is it possible then that it could rain too much? Yeah, so the output of wine in France in relationship to rain is probably maxed out. There's some ideal amount of rain again, right? So imagine that here is that optimal quantity of wine if there's this much rain. Now, if we start to have too much rain, we start costing ourselves some grapes and ultimately some wine. So that function might look like this. If we get totally flooded out with Noah, there's no wine, right? So there's some amount of rain that washes all the grapes away, and they're all worthless. So that function might look like that. But if we look at French wine versus California rain, they're unrelated.
So depending, like your line would either be curved or straight depending on what you're.
Depending on what the circumstances are between the two, yes.
So in that graph is showing the maximum point?
Yeah, this one would be a variation. Now, if I would have put rain in France here and output of wine, of French wine here, this would look like this. Same one we just did, right? Now, because this is not math class, remember this is not the x-axis, this is not the y, I'm perfectly at liberty to put those things that way. Okay. All right, so those are unrelated. Slopes. Rise over run. Now, the author here put it in x's and y's, which I hate, but x-rays and yo-yos, if we need to. But rise over run. So I don't know how you remembered it when you learned it once upon a time, but if you're doing it this way, the rise is the y-axis, and so the slope would be change in y over change in x. So those triangles, that's a math notation for the word change, which I use quite a bit in class. But what I'm just trying to remember is good old rise over run. And rise over run works with curves too. So we can rise or fall, in this case, from point A to point B. We drop this amount, which projects itself over to here. This is going from 10 to 6. We dropped our change in y is 4 minus 4. And we run from 110 to 100, or from 100 to 110. Our change in x is equal to a positive 10. So our rise over our run at point between points A and B is negative 4 over 10. 4 tenths, 0.4. Negative 0.4. And that's the slope of this curve at between those 2 points. What I went through in class was just to remember that this is a simplification of the slope of this curve. It's actually the slope of a straight line that connects those 2 points. So the rise of the run is really the slope of that line technically, the slope of the line, because some of your tests, either test or homework questions have this, if I was to say, what is the slope at this point, let's call it C, 1 point on the curve, then we do that tangent line thing, where the line is just kissing. Now you can see why that works pretty good, right? At the edge of my marker here, I don't have my golf club, so I can't use that awesome convention, but the slope of the line that just kisses that point C is basically the same as the slope between A and B. And so they're basically the same thing. And I think that's our next picture, I think. Let me just pause there. This is really important. Questions on slope?
So to find that answer, isn't it y2 minus y1 over x2? Well, x2 minus x1 over y2 minus y1?
The Y's are your right.
I got
Yeah.
a little mixed up with what you said, but this change in y,
So if-
you could do y2 minus y1.
Right.
Yeah.
Because that's how
And it
I,
went down.
Is that how you remember doing it?
Yeah,
right.
that's how I do it.
Negative
Yeah.
4 divided by
Yeah.
negative 10 is not.
And
It's
so
0.4. It's negative.
these
Oh, I was like,
these x1s and x2. So one thing that's important is that your 2's match up with each other, right? So when we talk about the way you did it there, this would maybe be, I guess it doesn't really matter, but y1 and this is y2. You want to make sure that we've got this one is x1 and x2.
That's how I've been doing homework.
Yep, that's fine. Okay, whatever works. That's why I try not to put too much into this like one way, because different teachers have different ways. You guys learned it different. You took it at different times in your life. So some of you had it in junior high, some of you had it in high school, some of you haven't seen it for a while. Maybe you had it in college. So we're all across the board. That's why we need to equalize the playing field with this chapter. Anything else on slopes? Again, this being upward sloping and increasing function means the slope is going to be positive. The rise over the run, both those numbers are going up, they're both positive. Whenever we have a function that's downward sloping, that slope is always going to be negative because the rise is really a fall. Or if you switch around your 2's and 1's on your x, y, y2, then your run is a negative run. We're going this way and then we're rising. Right? So either way, we're going to get a negative sign. Here's that tangent line. So the slope of this curve at point A is the tangent line, the slope of that tangent line. So then they're just doing a simple rise over run from that tangent line. I think you do that maybe once or twice in your homework problems where you have to look at the slope that way. But you just want to visualize that tangent line and then just do the rise over run business and you got it. Questions on that one? I think the next page is just this is just what we showed today, which we've done in the past with that other one we just did. If you've got 2 points, then a lot of times we'll just take the slope in between using the changes, which is what we did here. This is kind of blown up a little bit more. So you see between point A and B, kind of gives you that line there. Which is what we're doing with the demand curve. All right, and then this is huge. The slopes, or the shifts.
yeah, I didn't know what to use. They gave you 3 numbers, and only you 2 to point it, so I just gave it.
Okay. So the demand curve shifting would be kind of a classic here. Now here they try to use kind of non-econ things just to, we've got ice cream consumption and the price. So that's a demand curve. So the demand curve, when the temperature outside is 70 degrees, looks like this. which means at $2.75, people want to buy 10 ice cream cones. So there's our our demand curve for that. If the price falls to $2, they're going to buy more. The law of demand says they're going to buy more. So there's a whole bunch of prices and quantities when the temperature is 70 degrees out. If you ramp up the temperature to 90, people want to buy more all of a sudden. So at 275, they used to want to buy 10 ice cream cones, but now that it's so stinking hot out, I'm going to buy 20. At 250, I used to want to buy this much, now I want to buy this much. At $2, I used to want to buy this much when it's 70 degrees out, but now that it's 90, I want to buy this much. So that is relocating the curve. So on our demand curve, we talked about all the shifters of income and price of related goods, and that was the things we worked on with that. The supply curve is the same way. We'd have an upward sloping curve, holding constant those ceteris paribus things, and then we'd have the same thing going on. So if you get confused on shifts, this is a pretty good explanation here on when other things change. Any questions on that? All right, well, don't be afraid after class sometime if you've worked through a homework and it was another math area that stumped you. Hopefully you really got a good idea after working through this today that you can go use this as a resource and maybe double check, but don't hesitate to ask me to. And I'll try to help you out on that.
Is the quiz, should we do the quiz again now? Or is it
Yes,
closed?
yep. The quiz will be, I'll open it up again. So yeah, I do want you to work through it until you get it passed.